Good morning, sir.
Good morning. Start with 5 questions. We have already did last class. So just this is the revision you can say, or just we are starting the questions.
इसका चालू हो गया बेटा क्लास।
Starting with the first one, you have remembered this was the question we've already did in last class. So obviously all you are getting the answer. How to go for the answer, how to write down the answer. Please see this carefully. In the binomial expansion, this is the first kind of question where two binomials are given in this form. So step first, always you have to write down either TR term or TR plus 1 term. We know that if series is starting from 0, so it's better to write down TR plus 1 term. This will be NCR into NC and minus R, right? This is writing down the first term. And step 2, apply summation on this. While applying the summation, carefully watch the number, right? This is started from 0 and going up to n. So The complete series is there starting from 0 and going up to n, right? Now, how to solve this? See, NCR, we know that this is in the expansion of 1 plus x to the power n, coefficient of x to the power r. And again, NC, n minus r, in the expansion of 1 plus x to the power n, coefficient of x to the power n minus r. The trick is you have to understand, okay, like one number you are taking as x to the power r, second number you have to take for n minus r. So r will be cancelling out in both the cases. So if you'll see, in first case, it's x to the power r. In second case, it's x to the power n minus r. So overall, we can say from these two, that's the step 4. In the expansion of 1 plus x to the power 2n, coefficient of x to the power r plus n minus r, that's x to the power n. And this is known as 2n Cn. Hope everyone is getting this. Step 5th, the answer. Easiest way to get the answer, start with tr plus 1 term and solve up to, right, 1 plus x to the power 2n, x to the power n. Look in the second question again. The same concept we can apply to n plus 1 c naught square, to n plus 1 c1, and so on. So step first is tr plus 1 term is 2n plus 1 c naught into 2n plus 1 c naught, right? In place of naught, we have to write down r. Okay, 2n plus 1 cr, but the next step, when we are starting with this 0 to n, complete series, look, this is 2n plus 1 cr into 2n plus 1 c, 2n plus 1 minus r. So overall, what you are getting in this case is, in the expansion of 1 plus x to the power 2n plus 1, coefficient of x to the power r, 1 plus x to the power 2n plus 1, coefficient of x to the power 2n plus 1 minus r. So overall, right, we have to multiply both the numbers, and we are getting, in the expansion of 1 plus x to the power 2n, this will be 4n plus 2 x to the power 2n plus 1, or this will be 4n plus 2c 2n plus 1. The second one, hope everyone is getting. Now we have to start with the series. So it's a little bit different from others. Third one. Everyone try to solve this. This time it's c1 square plus 2c2 square up to ncn square. Like, I'm giving you 2 minutes to think about this question, okay, how to go for this, how to proceed this one. Again, the same question is there, but the number 1 to 0, 1, 2, 3, 4, 0, I'm saying for NC naught square, right? 0, 1, 2, 3 up to N are coming. In this question, we can start with TR term because this R is starting from 1. So this will be NCR square into R. This is 1, 2, 3 up to N. So I'm writing R for that. And this is NC1, NC2, NC3, NCN. So this is NCR square, right? Summation TR is equals to summation R into NCR into NCR. It's R starting from 1 to N, R starting from 1 to N. Now, this is the summation. This is known as S. Now, this NCR into R is N upon R into R into N minus 1 CR minus 1 into NCR. RR cancel out. N will be common out from this. N will be common out from this. You are getting R is equal to 1 to N, N minus 1 CR minus 1 into NCR. Now we have to apply the same fundamental what we have used in previous questions. Like, look, this is from the expansion 1 plus x to the power n minus 1, coefficient of x to the power r minus 1. Again, this is in the expansion of 1 plus x to the power n, coefficient of x to the power n minus r, but we know that this term also we can write this term as nc n minus r. It's better to write down n minus r, so we can cancel out this r and directly we can write down the answer, and this complete thing is multiplied with n. So I'm getting n into, from both this I'm getting 12 minus 1 Cn minus 1. Right? If you'll add both the powers, you are getting n minus 1. If you add both the power, you are getting 2n minus 1. Right? So n into 2n minus 1 Cn minus 1. How many of you have done this and getting the same answer? Write down yes in chat, please. Aska, very good, Aska. Very good. Aditya, very good. Shubham, very good. Very good. So the same questions are there, but you have to be careful, right, while solving the questions, right? Hope you have noted this. Right. Now, question number 4. Everyone, 2 minutes for you, then I'll solve. Almost the same question is there, right? What you have solved. So carefully. Lot many different methods are there, right? But this is one of the easiest method. Only you have to use the basic formula, and within a 2-3 line, you can write down the answer, right? So just try to pick up the concept and apply this, right? This time, I'm expecting like more than 90% student will get the answer. Meanwhile, few of the students are joining from late, so just I'm briefing this. Okay, 5 questions this I have given for the revision purpose, or we can say I have to start from there, right? These 5 questions, solution of first one, right? We have already did this question in previous class. Last class we did this. The second one, again the same question as the first one, applying the same concept, right? This is very important, right? Third question. First write down TR term, then apply the summation, right? Cancel out the R. Now apply the concept again for n minus 1 CR minus 1, 1 plus x to the power n minus 1 expansion, and 1 plus x to the power n expansion, and you are getting this, right? So the fourth question based on this only, right, for you. If you've done, write down the very good, very good. We have to start from the step first. Step first mean I have to write down TR or TR plus 1 term. It's better to write down TR plus 1 term because it's starting from 0. So this will be 2R plus 1 into NCR into NCR. Right? Step second, summation of TR plus 1 term, R is equal to 0 to N, is summation 2R plus 1 NCR into NCR, R is equal to 0 to N. Now, this is S summation 2 common out summation R into NCR plus summation R is equal to 0 to N NCR. Very good, everyone. Very good. Good going. Now, step 4. I guess you can write down the answer. This N by R taken from this and write down the answer. Everyone, try this. After this step, you have to write down the answer. Very good. Jebel, very good. Suyas, very good. Amog, very good. Snikta, very good. Asmi, very good. Now, this is 2 into n. This will be n minus 1 c r minus 1 n by r. N is cancelling out, right? N is common out from this. R is cancelling out from there, right? 2n minus 1 cn or 2n minus 1 cn minus 1 both are same. Plus, for this will be 2n cn. How many of you got right answer for this? Write down yes in chat, please. Anushka, very good. Arnav, Rakshit, Subham, Asmi, Suyas. Wow, great. Sunikta, very good. Right? So different questions are there, but same concept, same thing you have to use carefully, right? And it's an interesting part. Now, icing on the cake, you can say now its numbers are coming on the division, right? So now you have to apply the same concept, same theory, same thing, and crack this. Go. Use, very good, Vaishnavi. Very good. Retain, Dhruv, is it okay? Ansuman, Aswin, Dharmil, Manas, Naman. Be ready, everyone. Uday, Artinav, be ready. Utsav, Vinit. Simple question, go with ease. You can do that. सिंपल क्वेश्चन है. वेरी गुड अमोक, सुयस, शुभम, जेबल. Right? 1 by n plus 1, n plus 1 cr plus 1, n cn minus r. So this is 1 by n plus 1 to n plus 1 c n plus 1. Snikta, not r, not r. No problem, but I guess everyone is getting this. How many of you are getting this answer? Write down yes in chat, please. Maybe these are like different things while writing the answer. That would be difficult. Okay. So with the same concept, we have to go for this 2n c0 square minus 2n c1 square plus 2n c2 square up to the last one minus 1 to the power n to n c 2n square. This is, right? This is whole square term. Everywhere it's coming as whole square term. Or maybe the question will be asked as not 2 is there, right? C1 square, not 2 is there, not 2 is there, not 2 is there, right? C0 square minus C1 square plus C2 square up to n C1 square minus 1 to the power n, right? Find. Right? Maybe this could be given in the 2n form or n form. Just we are trying the n form only, right? That will be more complicated. So that would be good for us, right? So again, 2 minutes. उदय एक बार फिर कोशिश करें आप। Very good, Subham. But it's n, not 2n. C. Obviously, we'll start with just tr plus 1 term minus 1 to the power r ncr into ncr, right? So if you'll see this carefully, right, the second fundamental we have to apply, r is equal to 0 to n, summation r is equal to 0 to n. R is equal to 0 to n. We can write this complete as, right, minus 1 to the power r ncr as 1 and ncr as second. We know that by concept, this is nothing but in the expansion of 1 minus x to the power n, coefficient of x to the power r. And we can rewrite this as, because we know that ncr is same as nc n minus r. So in the expansion of 1 plus x to the power n, coefficient of x to the power n minus r, right? From both this, we can rewrite this 1 minus x squared to the power n. We need coefficient of x to the power n, but we have to understand this. The expansion is for x square, and here x is given, so expansion will not go right? So if really you want to write down the expansion in right form, so first we have to write it down as in the expansion of 1 minus x squared to the power n, this will be x squared to the power n by 2. Now I can say, oh, it's good. Both the terms, right? This is x squared, this is also x squared. If you want to put x squared as z, so you'll be able to put x squared as z. So what we can write this now? nc n by 2 minus 1 to the power n by 2. So if case first, n is odd, so not possible, answer will be 0. If n is even, then answer will be minus 1 to the power n by 2 nc n by 2. Carefully note down this. This is a little bit different. Done, everyone?
Yes.
So careful, this is a little bit different. Now, in all the cases, the previous cases, we have seen this NCR, where N was fixed and R वेरिएबल, राइट। अब तक जितने भी केसेस हमने देखे यहाँ पर, इसमें ये फिक्स रखा हमने, ये जो n था मेरे पास वो फिक्स था एंड r मेरे पास वेरिएबल था, राइट। सो नाउ आई एम चेंजिंग समथिंग कि इफ आई एम गिविंग NCR, दिस केस फर्स्ट, n is variable, r is fixed, or NCR, this is variable, this is again variable, right? Then how to solve this? Whatever question it could be, कैसे frame किए जा सकते हैं? So I'll start with a simple example on this, like 1C1, 2C1, 3C1, 4C1, up to 100C1, right? You can see in this example, n is variable and the r is fixed. In second way, 1C0, 2C1, 3C2, 4C3, 100C, 99. If you will see this carefully, ये दोनों क्वेश्चन सेम क्वेश्चन लिखे हुए हैं, राइट। ये दोनों क्वेश्चन सेम क्वेश्चन लिखे हुए हैं. सो इफ दिस इज गिवन इन दिस फॉर्म, राइट, कि n वेरिएबल या r वेरिएबल की बात हो रही है, तो एक्चुअल में दोनों सेम बात हो रही है, जिसको बोलने के तरीके अलग अलग होते हैं. सो अभी जो लाइक वी आर गोइंग टू स्टडी दिस थिंग, ये जो हम लोग स्टडी करने जा रहे हैं, इसमें ये हमारे पास like the question will be in such a form where n and r both are variable, or we can say कि n is variable and r is fixed, r is constant. So दोनों possibility हमारे पास होगा, right? But both are the same question, दोनों में difference कुछ भी नहीं है. So चलो one by one we'll go for that. So question, NC0 plus n plus 1 C1 plus n plus 2 C2 up to n plus r CR, right? इसकी वैल्यू निकालनी है. We have two different methods to solve this, right? Going with the first one, with the basic method. What is this basic method? NC not n plus 1 C1 and blah 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 n plus r CR. We can rewrite this and make all the base same. We know that NCA is equal to NCB, then A plus B is equal to N, or A is equal to B. So applying A plus B is equal to N, so NC naught is same as NCN. N plus 1 C1 is same as N plus 1 CN, N plus 2 C2 is N plus 2 CN, and so on, right? Now, in this expansion, you can see this. This is in the expansion of 1 plus x to the power n, coefficient of x to the power n. Second one, right? Second one is in the expansion of 1 plus x to the power n plus 1, coefficient of x to the power 1. Third one, in the expansion of 1 plus x to the power n plus 2, coefficient of x to the power n. Fourth one, and blah 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 up to the last one. This is 1 plus x to the power n plus r, coefficient of x to the power n, right? So overall, this is the question. So what I'm rewriting from this step, I'm saying, okay, it's good. Okay, every time we have to find coefficient of x to the power n in the expansion of like 1 plus x to the power n, 1 plus x to the power n plus 1, and so on. So we can write down, find coefficient of x to the power n in the expansion of 1 plus x to the power n plus 1 plus x to the power n plus 1 plus 1 plus x to the power n plus 2 up to 1 plus x to the power n plus r. Okay, we have to find coefficient of x to the power r n in this expansion. Hope everyone is getting this. Now, if you'll see this carefully, these terms, clearly these terms are in GP, right? So you have to solve the GP. The first term is 1 plus x to the power n. Common ratio r is 1 plus x only, and total number of terms starting with 0 going to r, the total number of terms is r plus 1, right? So what we are getting, and from that we have to find coefficient of x to the power n, right? A 1 plus x to the power, right, total number of terms, minus 1 upon 1 plus x minus 1, right? In this, we required coefficient of x to the power n. 1, 1 cancel out. Okay, please note down. Up to this, then last step is very important and very, like, it's a little bit we have to understand for further question. So that we'll do. So please note down up to this, then we'll go further. 2 minutes. So the interesting last step on this is, carefully everyone, we need coefficient of x to the power n, right? So okay, coefficient of x to the power n in the expansion of this complete thing is given, right? The complete this thing is given. What is given there, right? Look, this when multiply, this will be 1 plus x to the power n plus r plus 1 minus 1 plus x to the power n, and whole thing divided by x. right? In this expansion, we need coefficient of x to the power n, right? And x is there, we are dividing this by x. So the term x to the power n will come from this when we are getting term of n plus 1 from this. If we'll get x to the power n plus 1 from this complete there, then only we can say that will be coefficient of x to the power n, because one x will be cancelling out from this to this one. Hope everyone is getting this. So my question is coefficient of n plus 1 from the numerator one, right? From the numerator one. Obviously, we know that coefficient of x to the power n plus 1 is n plus r plus 1 c n plus 1 minus 0. This expansion is going up to x to the power n only, so we are not able to get the term of x to the power n plus 1. So we are writing for this answer will be 0, and for this it's directly the answer is coming on this part. So my answer for this question will be something like this. Again, note down please. So this is the first method, right? Interesting method. We have applied GP. With the help of GP, we are doing this, and hope everyone is getting this. And a simple thing we are getting, right? But the same question we have to do with different methods. Hope you like that method. Done. So the question was NCN to NCR, right? The original question was this: NC naught, NC1, n plus 1. Okay. NC naught plus n plus 1 and blah, 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 right? So let's suppose I'm writing this as NC naught. Value of this is 1 only, right? Value of this is 1 only. I'm saying, okay, I'm writing this as n plus 1 C naught. NC naught is same as n plus 1 C naught. Both the values are 1, right? And again, starting the question, right? We know one of the simplest formula याद होगा NCR plus n plus 1 C NCR plus NC R plus 1, right? NCR plus NCR plus 1. In the previous lecture, we have done this formula. N plus 1 CR plus 1. Hope ये formula सभी को याद है, right? A simple formula, basic formula, but very useful formula. See, if I'll apply this formula there, इन दोनों में मैंने apply किया, तो what I'm getting n plus 2 C1 plus, आगे क्वेश्चन को फिर वही लिखता हूँ n plus 2 C2 plus n plus 3 C3 and so on up to n plus R CR. Again, I'm applying this formula on this, so I'm getting n plus 3 C2. आगे जो भी था उसे वैसा ही लिखता हूँ, राइट? अगेन इसी फॉर्मूला को मैं एक स्टेप और आगे अप्लाई करता हूँ. सो दिस विल बी n plus 4 C4 एंड ये प्रोसेस मेरा चलता जाएगा. व्हाट आई एम गेटिंग, राइट? राइट, एंड इन दोनों को जब ऐड करूंगा तो n plus r plus 1 cr. So you are getting answer on this. एक बेसिक फॉर्मूला मैंने यूज किया, and we are getting the answer. Please note down. This is called the catalyst effect. Catalyst effect means something you have to like give to the uh, give for the reaction, and when the reaction starts, it's go like it's a controlled reaction, go up to n plus r cr. So if I'm applying this formula, this already given there, right? This formula on this form, right? N plus 1 C naught plus N plus 1 C1. So 100% these two will be going to be, right, N plus 2 C2, N plus 2 C1. Now N plus 2 C1 and N plus 2 C2, this will be N plus n plus 3 C2. Now n plus 3 C2 and n plus 3 C3, then this will be n plus 4 C4 and so on, blah, 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 blah. So I'm applying the same formula. So going up to like the last term, what you are getting. Hope everyone is getting this formula. This question also, the basic but a very useful question. This is called vendor mod method. And if n and r both are variable, right, you can use, and both the methods are very important, right? You can't say ki like first is okay, second is not okay, right? Maybe the question would be asked for different forms, that you have to be careful while solving the question, right? Like solve this. Try this one. 2n cm, 2n minus 1 cm up to m cm. You have both the methods. So try. Done. Very good, Asmi. See, in these type of question, right, the main thing is rewriting the question to get this. Like, I'll start from MCM, M plus 1 cm, M plus 2 cm, up to 2n cm, right? First, rewrite the question in this form. This MCM, I'm writing as this term as M plus 1 C M plus 1 plus M plus 1 cm plus M plus 2 cm up to 2n cm. If I'll add these two terms, so what we are getting, M plus 2 C M plus 1. Now adding these two terms, what I'm getting, M plus 3 C M plus 1. Now adding with the other one, M plus 4 C M plus 1. Now adding with the last one, I'm getting, right, the previous to this one, to 2n C M plus 1. Right, and the last one, so one term will be there, 2n plus 1 C M plus 1. How many of you are getting this answer? Write down yes in chat, please. Very good. Aditya, very good. Sagar, very good. Pritin, very good. Else you can go with the method of GP series. That's also okay, but this is the simplest method. Like, you can solve this. Little bit you have to be careful, okay, from the starting point. Like, before this, the number was 2n minus 1 cm, right? So when you add this, so from this you are getting in the expansion 2n c m plus 1. So now adding with this, so obviously you'll get 2n plus 1 c m plus 1. Okay, that's me, right? So one more question for you, right? So why I'm saying you have to use both the method, you will understand from this question. NC3 plus 2 into n plus 1 C3 plus 3 into n plus 2 C3 up to n into 2n minus 1 C3. Right? Try this. So in this question, we can also go for different method. Very good, Sagar. Look, this is in the expansion of 1 plus x to the power n coefficient of x to the power 3, 2 into in the expansion of 1 plus x to the power n plus 1 coefficient of x plus 3, 3 into 1 plus x to the power n plus 2, and n into 1 plus x to the power 2n minus 1 coefficient of x to the power 3. Coefficient of x to the power 3 in overall expansion that we have to find. Do it fast. So first thing what we can do is this. So we have to find the series only, right? S is equals to 1 plus x to the power n plus 2 into 1 plus x to the power n plus 1 up to n into 1 plus x to the power 2n minus 1, right? It's a simply AGP series, right? So simple direct AGP series that we have to solve, and we know that like in like AGP series, how to solve. You have to multiply with R, the common ratio, right? Then we'll get a series, and that will be like 1 plus x into s, 1 plus x to the power n plus 1, plus 2 into 1 plus x to the power n plus 2. Last is n minus 1 into 1 plus x to the power 2n minus 1, plus n into 1 plus x to the power 2n. Subtract both the terms. While subtracting, you have to be careful. S 1 minus of this plus 1. So 1 cancel out. This is minus x. So only minus x is there. Is equals to 1 plus x to the power n plus 1 plus x to the power n plus 1 up to 1 plus x to the power 2n minus 1 minus n times 1 plus x to the power 2n. Divide this by x. Now, minus s of this, right? We need coefficient of x to the power 3 from the expansion. So we can say from the numerator part, we need coefficient of x to the power 4, right? Coefficient of x to the power 4 to पहले तो solve कर लें. So this is the GP series. First term is 1 plus x to the power n. Total number of terms starting with 0 and going up to, so again n minus 1 upon 1 plus x minus 1 minus n into 1 plus x to the power 2n. So this is coming as 1 plus x to the power 2n minus 1 plus x to the power n upon n minus n into 1 plus x to the power 2n. In the complete series, what we require is coefficient of, this is x, don't forget this, right? Coefficient of x to the power 3. So from numerator on this part, we need coefficient of x to the power 4, but from this we need coefficient of x to the power 3. So let's write down the answer. 2nc4 minus nc4 minus n into 2nc3 minus s is this one. So s is equal to n into 2nc3 plus nc4 minus 2nc4. Please note down. Right, here you have to be little bit careful. ये x square था, ये x था, so this would be, ये कोफिशिएंट थोड़े से चेंज हो जाने हैं आपके, and this will be nc5 5 4 and 4 5 5, क्योंकि एक x पहले से मेरे पास यहाँ से भी था, right? So 2x are there, so x square नीचे गया था. Printing mistake. Note down, please, everyone. Right, this is a very good question. So you have to be careful about these questions, right? काफी अच्छे स्टैंडर्ड के क्वेश्चन हैं. So while reaching to these questions, first you have to solve all the simple method questions and all, right? This is binomial series and vendor mod method के लिए हम लोगों ने यहाँ पर वर्किंग की. एक यहाँ पर बहुत प्यारी और भी सीरीज बनती है जो कॉम्प्लेक्स नंबर के साथ में बाइनोमियल को मिला के बनती है. कॉम्प्लेक्स एंड बाइनोमियल दोनों के साथ में ये वर्किंग होती है एंड इट्स वेरी गुड रियली. Hope everyone done with this. ये जितने भी सीरीज आपने देखे, ये सीरीज में बाइनोमियल तक जो देखा, एक बाइनोमियल के साथ में मैंने कहा कि कॉम्प्लेक्स नंबर भी यूज होता है. थोड़ा सा मेरे को यहाँ पर आपको ब्रीफ करना पड़ेगा. यू नो दैट आई स्क्वायर इज इक्वल टू -1 होता है. सेकंड, ओमेगा is a cube root of unity, thus omega cube is 1 and 1 plus omega square की वैल्यू 0 होती है. थोड़ा सा मैं ब्रीफ कर दूं कि what is this omega. See, x cube is equal to 1. x cube is equal to 1 के how many roots are there for x cube is equal to 1? Write down in chat please. How many roots are there for x cube is equal to 1? Naman, Ritain, Subham, Sunikta, Kevin, Pranaya. Very good. Very good. Very good answer. Right. Few of you are saying 1 root. You are saying 3 roots. Actually, number of roots in this case are 3. 3 roots की बात हो रही है. Right. Number of roots इसमें जो है वो 3 है. इसमें 1 real and 2 imaginary. 1 real and 2 imaginary. Right? दोनों आपके पास हैं. 1 real root and 2 imaginary roots. 1 real root is nothing but x is equal to 1 and 2 imaginary roots are omega and omega square. You can find the value like x minus 1 फैक्टर कॉमन लेने के बाद x स्क्वायर प्लस x प्लस 1 के 2 वैल्यूज आएंगे. तो वी हैव गिवन अ नेम ऑफ दिस इज ओमेगा एंड ओमेगा स्क्वायर. सो वी हैव जनरेटेड द फॉर्मूला दिस omega cube is equal to 1 and 1 plus omega square is 0, right? So we're getting 2 things, right? ये 2 चीजें हैं जो अप्लाई होती है. and I square is equal to -1, you know, right? I square is equal to -1 or I is equal to under root of -1. So you can apply the formula for this also, right? So what is the use of this? कि बाइनोमियल एंड कॉम्प्लेक्स दोनों को अगर मैं यूज कर रहा हूं तो कैसे क्वेश्चंस होंगे और किस तरह से. आपको कहीं भी कॉम्प्लेक्स का नाम क्वेश्चन पे नहीं रहेगा, बट यू हैव टू अंडरस्टैंड दिस. C0 minus C2 plus C4 minus C6, and this will be, I don't know, NCN में n is even or odd, or n even भी है तो even में multiple of 4 है या multiple of 2 है, remainder 2 के साथ में है. So NCN के साथ में it's depend on plus or minus sign, I don't know, right? So this is the like series. We have to find value of this, right? Either there would be a plus sign or minus sign. दोनों तो एक साथ नहीं हो सकते हैं, right? So this is the question. अब ये क्वेश्चन में अगर ध्यान से देखो तो प्रीवियसली हम लोगों ने जब क्वेश्चन किया था तो उसमें हमारे पास था, इट वाज रिटन एज NC0, NC2, NC4 अप टू NCN की वैल्यू थी, वो थी 2 to the power n-1, राइट। दिस वाज गिवन 2 to the power n-1। अब उसके बियॉन्ड वी हैव टू गो, एंड मेरे को यहाँ पर माइनस साइन के साथ में चाहिए कि अब क्या होगा, राइट। ये एक्सपेंशन में किस तरह से मेरे को सीरीज लानी है और ये सीरीज को कैसे सॉल्व करना है, राइट। प्लस माइनस साइन दोनों जा रहे हैं। सी, तो वी हैव टू गो टू द बेसिक, फिर से बेसिक पर एक बार चलना होगा। सो बेसिक वाज 1 plus x to the power n, nc0, nc1x plus nc2x square up to ncn x to the power n. Put x is equals to I, मैंने पुट किया x is equal to I, right. This is 1 plus I to the power n is nc0 माइनस nc1, क्योंकि मैं रियल पार्ट को एक साथ लिख रहा हूँ, इमेजिनरी पार्ट को अलग, माइनस nc2, nc4 and so on, real part, plus I into nc1 minus nc3 and so on, right. So this is the expansion, right. ये एक्सपेंशन होता है, एंड इसमें थोड़ा सा आपको कॉम्प्लेक्स नंबर पढ़ना पड़ेगा। इसका जो रियल पार्ट है वो इसके रियल पार्ट से इक्वेट करना पड़ेगा, इसे निकालने का तरीका रहता है। एंड इसका जो इमेजिनरी पार्ट रहता है वो भी इसके इमेजिनरी पार्ट से इक्वेट करना पड़ेगा, जिसको निकालने का तरीका रहता है जो आप आगे पढ़ोगे। लेकिन अभी क्यों बताया इसको, ये समझना। बहुत सारे क्वेश्चन मिलेंगे आपको जिसमें लाइक C0 प्लस C3 प्लस C6 प्लस C9, C0 में लिखना हो, इसका लाइक इनबिल्ट मीनिंग आप समझ के चलना कि दिस इज NC0, NC3, NC6, NC9, राइट। ये सीरीज है और इसकी आंसर निकालने आपको, ध्यान से। गो टू द बेसिक, मीन्स 1 plus x to the power n, C0 plus C1x plus C2x square plus C3x cube plus C4x to the power 4 up to Cn x to the power n, right? सी, ध्यान देना, एक छोटा सा फॉर्म बता रहा हूँ, फॉर्मूला बता रहा हूँ। इन दोनों के बीच का डिफरेंस क्या है? तो डिफरेंस इज 3, राइट। रेशियो, कॉमन रेशियो जो हर एक टर्म में आ रहे हैं वो क्या है? तो रेशियो इज 1, राइट। डिफरेंस जो 0, 3, 6, 9 ये जो नंबर्स आ रहे हैं, इसके डिफरेंसेस इज 3, and the number multiply with this if nothing is there, so 1 is multiplying, so ratio is 1. Maybe plus 1 minus 1 plus 1 minus 1 ये चलता जा रहा हो, so that's written in this form, right? So I वाले फॉर्म में शायद आपको 1 plus I के जो लास्ट फॉर्म था उसमें अभी बहुत सारी चीज़ें पढ़नी होगी इसको समझने के लिए, राइट। इसलिए मैंने कहा कि ये समझा तो देता हूँ, बट एग्जाम्पल ये समझो तो आपके लिए आसान पड़ेगा। तो अभी तक मैंने जो कहा ये क्या है, you have to take the differences 0 से 3, 3 से 6, 6 से 9, and ratio in each term is given as 1, right? So what you have to do, x to the power difference is equal to the ratio. x to the power difference is equal to the ratio. आपने जैसे ये वर्क किया तो यहाँ से कुछ x की वैल्यू आपके पास आ जाएगी, राइट। यहाँ से कुछ x की वैल्यूज आपके पास आ जाएगी। अगर आप ध्यान दो, यही x क्यूब की बात चल रही थी, उस x क्यूब में 3 वैल्यूज मेरे पास है। जो 3 वैल्यूज मेरे पास है वो है 1, ओमेगा एंड ओमेगा स्क्वायर। राइट, 1 ओमेगा ओमेगा स्क्वायर। सो इन द क्वेश्चन, ये जो क्वेश्चन आपके पास होगा उससे जो बेसिक हमने यहाँ रखा हुआ है, इसमें C0, C1 ये जो पूरे गिवन है, राइट। इसमें वी हैव टू पुट वैल्यू ऑफ x एज 1 टाइम 1, फिर ओमेगा एंड ओमेगा स्क्वायर। दिखाता हूँ क्या होगा, कितना प्यारे तरीके से क्वेश्चन itself will give you the answer. क्वेश्चन अपने आप में आपको आंसर दे रहा होगा. कैसे? पहले मैंने 1 पुट किया, so 1 पर this will be 2 to the power n is equal to c0 plus c1 omega plus c2 omega square plus c3 omega cube is 1 plus c4 omega to the power 4 is same as omega, c5 omega to the power 5 is omega square, फिर c6 and so on. ये चल रहा है. सेकंड में मैंने क्या पुट किया, राइट? तो सेकंड में आई एम पुटिंग ओमेगा. 1 plus omega to the power n is c0 plus c1, राइट? ओह, फर्स्ट वन में, ये पहले वाले में मैंने ओमेगा पुट किया है, 1 प्लस ओमेगा. सेकंड वाले में मैं पुट करता हूं ओमेगा स्क्वायर, राइट? ओमेगा स्क्वायर c2 ओमेगा टू द पावर 4 इज सेम एज ओमेगा, राइट? c3 ओमेगा टू द पावर 6, c4 ओमेगा स्क्वायर एंड सो ऑन. ये भी गया. थर्ड में मैं 1 पुट करता हूं, तो दिस इज 2 टू द पावर n, c0 प्लस c1 प्लस c2 प्लस c3 प्लस c4 एंड सो ऑन. राइट? तीनों को ऐड किया, 2 टू द पावर n, 1 प्लस ओमेगा टू द पावर n, 1 प्लस ओमेगा स्क्वायर टू द पावर n इज इक्वल टू, ध्यान से देखना, ये तीनों नंबर हो गए 3 c0. ये तीन नंबर जो हैं, अगर मैं c1 कॉमन ले लूं तो मेरे पास आएगा 1 प्लस ओमेगा स्क्वायर, जो कि 0 होता है. c2 कॉमन लिया, 1 प्लस ओमेगा स्क्वायर 0 होता है, दैट्स c3, फिर 0 0, फिर c6, देन c9 and so on. So overall what you are getting, 2 to the power n plus 1 plus omega to the power n plus 1 plus omega square to the power n upon 3. So this is c0 plus c3 plus c6 plus c9, right? So directly you are getting the answer of this, right? एक बहुत टफ टाइप के क्वेश्चंस को सॉल्व करने का ये तरीका है, राइट? प्लीज नोट डाउन. कॉम्प्लेक्स के बाद में इट विल बी मोर like you'll find this one of the easiest thing, right? कॉम्प्लेक्स पढ़ने के बाद में you'll find this would be the one of the easiest thing, but फिर भी अभी फॉर्मूला क्या बन रहा है, कैसे बन रहा है, you have to write it down. Okay, if you are finding any difficulties ना कि इसमें जूम में देखने में दिक्कत जा रही हो या समथिंग, तो now we are live on YouTube also, right? तो YouTube में भी आप जाके देख सकते हो ना. YouTube में भी लाइव आ रहा होगा, आई गेस यही के यही पूरे पिक्चर्स सारे होंगे आपके पास. You can go to YouTube. It's coming. Write down yes if it's coming.
Yes, sir.
Yes, sir. आ रहा है.
Okay. इट्स अ ब्यूटीफुल कंसेप्ट, राइट? मैं काफ़ी सारे ऐसे क्वेश्चंस होंगे जब जंप बहुत बड़ा हो रहा हो, 0 c0 c3 c6 c9, राइट? इस तरह की जंपिंग होंगे ना, तो लाइक कॉम्प्लेक्स को सॉल्व करना, ऑब्वियसली कॉम्प्लेक्स एक नया कॉम्प्लेक्स इज नॉट कॉम्प्लेक्स, राइट? कॉम्प्लेक्स इज वेरी सिंपल, बट इट्स अ न्यू मैथमेटिक्स दैट वी हैव टू स्टडी. वो उसे हमें पढ़ना पड़ेगा, राइट? उसे हम लोगों को देखना पड़ेगा, पढ़ना पड़ेगा, बट ऑब्वियसली इसके लिए हम लोग को ख्याल रखना पड़ेगा कि वी कैन गो देयर आल्सो.
So,
यस प्लीज.
Sir, can you please explain 1 plus omega square raised to n expansion?
1 plus, in place of x, put omega only. In the expansion 1 plus x to the power n, in place of x, we have to put omega only. So C naught
So
is C
omega
naught, C
square.
omega square. In place of x, you have to put omega square. So omega to the power 4 is coming. So we know that omega cube is 1. So omega to the power 4 is omega cube into omega. So that will be omega only, omega to the power 5. So we know that omega to the power 5 is nothing but its value omega to the power 5 means omega cube into omega square. So omega square is there. Omega to the power 6 means 1. Omega to the power 7. So omega to the power 6 is 1, 2. That value will be omega. So later on, like the same way, you can write the
Okay,
numbers,
sir.
reduce in the form of 1 omega and omega square. Right? 1 omega and omega square.
Okay, sir.
Right? Like I'm giving you one more question on this. ख्याल रखना ये सब आगे जाके काफी अधिक यूज होने हैं. I'm giving you like C0 plus C4 plus C8 plus C12 and n is there, right? So find value of this. Try to write down the answer, everyone. See, in this case, the difference is 4, right? Difference is 4, right? And the numbers are given, there is 1, 1, 1, 1. So ratio is 1 only. Means x to the power 4 is equal to 1, means x is equal to plus minus 1 and plus minus I. 4 values are there. Very good, very good. Kevin, very good. 4 values are there, right? So if you want to write down the answer directly, I'm saying one value will be this, the expansion will be there. Other value will be this, the expansion would be there, right? I expansion will be there. 1 minus I expansion will be there. If you'll add all 4, you are getting 2 to the power n, 1 plus I to the power n, 1 minus I to the power n plus 0 by 4 is equal to your required answer. So only finding the roots can give you the answer, right? Only finding the roots will give you the answer. Okay. Okay. Right. One of the best way to get the answer, right? धीरे धीरे इसे और हम लोग आगे बढ़ाते जाएंगे, but obviously थोड़ा careful होते हुए, right? So everyone now get the booklets. सबके पास बुकलेट होगा, आई होप सो. मैंने भेजा भी था आप लोगों को, सर सभी के पास होंगे बुकलेट्स, राइट? तो नेक्स्ट 2 minutes you have to get the booklets. Okay. Hope you all have started the questions. You all have the booklets also. Right? So let's start. हम लोग वहाँ से कुछ questions करना चाह रहे हैं and I'll give you the question. Okay. So just I'm giving you question on that. If it is not given, so this is N na. This is NC, not NC1, NC2, and so on. Okay. Very good. Kevin, very good. Very good speed beta. That we required. Do it fast, everyone. Do it fast. Maximum 7 minutes. Very good. Snikta, Subham, Asmi, Ayush. Go for the second one. Let's start. The first question, it's 1 into and the AP binomial series, right? So AP binomial series, so this S is equal to, so reverse this thing. So we can write, add both the terms, so we can write the answer. AP बाइनोम के लिए इससे अच्छा क्या मेथड हो सकता है, right? Second is 3, 4, 4 difference again in AP, right? Add both the terms, 4n plus 2 into 2 to the power n minus 1. यहाँ से 2 अगर चाहते हो तो कॉमन ले लो आप. Again you are getting the answer, right? 1 से मैंने start किया, so this is coming from 1 and going up to, right? ये जितने भी क्वेश्चन हम लोगों ने किए थे वो सब सिंपल क्वेश्चन हैं जो यहाँ पर हमारे पास हैं, that you have to do, right? 2 to the power n plus 1 minus 1 upon n plus 1, right? एक ही क्वेश्चन बोल सकता हूँ, तो लास्ट वन, NCR 2r minus n the whole square. Everyone do it fast. कुछ स्पेशल सीरीज हैं जो हम लोगों को स्टडी करना है, बट नेक्स्ट क्लास तक मेक श्योर कि आप लोगों को कंप्लीट कर लेने हैं अपने बुकलेट्स, राइट? फिर मैं कुछ यहाँ से आगे के कुछ और अच्छे कंसेप्ट बताऊंगा. Last question, do it fast. Everyone, do it fast for last one. एवरीवन लुक केयरफुली। मेरी एक्सपेक्टेशन क्या है आप लोगों से, इस क्वेश्चन के थ्रू पता चल जाएगा आपको। मेरी एक्सपेक्टेशन थी इस क्वेश्चन के लिए कि यू विल थिंक इन दिस वे, एनसीआर को एनसीआर लिखा, एंड दिस यू आर राइटिंग आर माइनस एन माइनस आर द होल स्क्वायर, राइट, द समेशन। केयरफुल, r is equal to 0 to n. Expand this, you are getting r square plus n minus r the whole square minus 2r into n minus r, right, and complete into ncr the summation, right. Now see, we know that n minus r whole square, we can rewrite this as r square for the summation. So this is coming 2r square minus 2rn, right, plus 2r square into NCR, right? Or we can rewrite this as n minus r as r square. So in the simplest way we can solve the question, right? बहुत ही सिंपल तरीका हो सकता है क्वेश्चन को सॉल्व करने के लिए. Don't go for yes, very good Suyas, very good Suyas, right? तो थोड़ा सा ख्याल रखते हुए आप एक्सपैंड भी कर लो तब भी चलेगा, बट अगर पॉसिबल हो तो गो फॉर दिस, ये अधिक आसान आपको काम करेगा, सॉल्व करना आसान रहेगा. ओके, सो आज की क्लास को अगर ब्रीफ करूं तो हम लोगों ने सीरीज में स्पेशल सीरीज वेंडर मॉड बहुत इंपॉर्टेंट क्वेश्चंस किए हैं, बट कुछ और सीरीज हमारे पास बचे हुए हैं दैट यू हैव टू डू इन नेक्स्ट क्लास, राइट. सो नेक्स्ट क्लास में हम लोग कर रहे होंगे, सो प्लीज बी केयरफुल, राइट. नेक्स्ट क्लास के लिए हम लोग थोड़ा सा अपने आप को और तैयार करके रखें, तो डू द होमवर्क, राइट. ओके एवरीवन, थैंक यू.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you.
Sir,
Yes.
can you please resend the module in the group?
Okay, beta.
Module PDF.
Yeah, I'll send.